Humbert here, and today we're going to be doing Unit 8 Learning Target 12 notes. We're going to be talking about Pythagorean triples and applications. So we're going to be applying that Pythagorean theorem that you learned on the previous note video. So let's go ahead and let's recall what the Pythagorean theorem is. The Pythagorean theorem is a squared plus b squared is equal to c squared. Now remember, c squared always represents your hypotenuse sitting across from the right angle. So what is a Pythagorean triple then? So Pythagorean triple says that if three sides can satisfy the Pythagorean theorem, then they form a right triangle and we can call them a Pythagorean triple. So what we're going to be doing for starters is we're going to be taking a look at three numbers and seeing if they form a Pythagorean triple. So let's go ahead and let's take a look at that. So for number one, we want to see if these form a Pythagorean triple. So what we're going to do is we're going to take the two smaller sides and square them. And we need to see, okay, does that equal the larger side squared? Okay, so 21 squared is 441, and 20 squared is 400, and that's going to be equal to 29 squared, which is 841. We'll add those two together, and you get 841. Does 841 equal 841? Yes. So yes, those three numbers form a Pythagorean triple. So you can't just assume, you can't just say yes or no. You do have to actually write out the work showing me that this is true. So let's check this next one. So we're going to have our two shorter sides squared added to our longer side. So 8 squared is 64 plus 10 squared is 100, and that's equal to 12 squared, which is 144. Does 164 equal 144? No, it doesn't. So this is not a Pythagorean triple, so no. All right, let's take a look at number 3. So for number 3, we want to square our shorter side, so 9 squared plus 12 squared, and see if that's equal to 16 squared. So 9 squared is 81, 12 squared is 144, and 16 squared is going to be 256. So we're going to take 81 plus 144, and that's 225. Does 225 equal 256? No, it doesn't. So no, these numbers are not a Pythagorean triple. Taking a look at number 4, again, squaring the smaller sides, 10 squared plus 24 squared is equal to 26 squared. So 10 squared is 100, and then 24 squared is 576, and that's going to be equal to 676, or so we hope. So when you add those two together, you end up getting 676 is equal to 676. Is that true? Yes. So yes, number 4 is a Pythagorean triple. Taking a look at number 5, we want to see if 3, 4, and 5 are Pythagorean triples. So we're going to take the two smaller and square them and see if that equals the third one squared. Well, hey there, little reminder. Get out of my way. All right, so then we have 9 plus 16. Is that equal to 25? Is 25 equal to 25? Why, yes, it is. So yes, number 5 is a Pythagorean triple. Taking a look at number 6, our smaller two sides squared set equal to our larger side. So 5 squared is 25. 12 squared is 144. Is that going to be equal to 169? So we're going to take 25 and add it to 144. Is 169 equal to 169? Yes. Taking a look at number 7. So we want to see if the two smaller sides squared, so 9 squared plus 40 squared, is that going to be equal to 41 squared? And then we have 81 plus 1,600. Is that going to be equal to 1,681? Because that's what 41 squared is. Well, 81 plus 1,600 is 1,681. Is that equal to 1,681? Sure is. So yes, number 7 is a Pythagorean triple. Taking a look at number 8 now. So for number 8, we're going to have 11 squared plus 60 squared. Remember, your two smaller sides squared equal to your larger side squared. So 11 squared is going to give you 121. 60 squared is going to give you 3,600. And 61 squared is 3,721. So when you add those two together, you end up getting 3,721. Is that equal to 3,721? Yes, it is. Again, you have to show this work because you're asked to show if it is a right triangle. All right, so let's go ahead, and it asks us what the area of triangle ABC is. Well, to calculate out the area of a triangle, you need to do 1/2 base times height. Well, we already have our base. What we don't have is our height. So what I have to do is I have to use the Pythagorean theorem to figure out what my height is going to be. So I notice that x is one of my legs. So I have x squared plus 12 squared is equal to 20 squared. So I get x squared plus 144 is equal to 400. Then we're going to subtract 144 from both sides, and we end up getting x squared is equal to 256. Now, I don't want to know what x squared is. I want to know what x is. Well, when I take the square root of both sides, conveniently, it works out to be just 16. So I don't even have to simplify the radical. And now I'm going to go ahead and calculate out my area. So my area is going to be 1/2 times my base, which is 12, times the height of my triangle, which is 16. So 1/2 times base times height, and that's going to be equal to 96. And since they didn't give us a label, we don't need to give them a label. Let's take a look at this one. A square shopping center has a diagonal walkway from one corner to the other. If the walkway is about 70 meters long, what is the approximate length of each side? So here's our square shopping center. We have a diagonal cutting down that's 70. Well, since it's square, I know that both of these sides are the same length, and likewise, I have a right angle. Now, I don't happen to know either of my legs, but since both of my legs are the same length, I can use the Pythagorean theorem because I can do x squared plus x squared is equal to 70 squared. So then I get 2x squared is equal to 4,900. And now I need to solve that for x squared. So the first thing I need to do is I need to divide both sides by 2. And then I get that x squared is equal to 2,450. And now I need to take the square root of both sides. And that actually doesn't work out to be a radical, at least not that I remember. So let's go ahead and let's break it down into a simplified radical. Well, I see that it ends in 50, so that means it's going to be divisible by 50. So I end up getting 50 and 49. Well, 49 I know I can break down to 7 and 7. 50 I can break down to 25 and 2. 25 I can break down to 5 and 5. So then I'm going to have a pair of 5s and a pair of 7s that can come on out of that radical. So I have 5 times 7, and left underneath the radical is 2. 5 times 7 is 35, and left underneath the radical is that 2. The original label for the walkway was meters, so the length of each side is also going to be meters for number 10. Taking a look at number 11, if the perimeter of square 1 is 160 units and the perimeter of square 2 is 120 units, what is the perimeter of square 3? So if the perimeter is 160 units, that means if we divide it by 4, we can get each side length. So for square 1, you're going to get 40. So this side length right here is 40. And then if you take 120 and divide it by 4, you end up getting 30. So this side length is 30. So what I have in the center is a right triangle with sides 40 and 30. So what I'm going to do now is I am going to do the Pythagorean theorem on the right triangle. So I have 30 here and I have 40 here. So I'm going to do 30 squared plus 40 squared is equal to x squared. So 30 squared is 900. 40 squared is 1,600, and that's equal to x squared. So when I add those two together, I end up getting that x squared is equal to 2,500. So then I'm going to go ahead and take the square root of both sides. And thankfully, the square root is actually a whole number. When I take the square root of that, I end up getting 50. So 50 units is the length of this side. Now, the question is asking us for the perimeter. So the perimeter, so each side of that square is going to be 50 units. So all I have to do is take 50 and multiply it by 4, representing each side of the square. So 50 times 4 is 200 units. So the perimeter of that square is 200 units. Let's take a look at number 12. So for number 12, it says that a fireman's ladder is 100 feet long. So what we have here is we have a house. So there's my house right there, and it is a beautiful house. Okay, so we have a ladder coming down off it, and we're saying that that ladder is 100 feet long. It reaches a point on a building that is 80 feet above the ground. So the height that it reaches up this way is 80 feet. So we want to figure out how far it's sticking out here. And so what we're actually given then in that diagram is a right triangle. We have a hypotenuse of 100 because the house is going to form a 90-degree angle with the ground. And we have a side of 80 and a horizontal length of x. So then I'm going to get 80 squared plus x squared is equal to 100 squared. So 80 squared is 6,400 plus x squared is equal to 100 squared, which is 10,000. So then when you add, so now what I'm going to do is I'm going to subtract 6,400 from both sides. And bring this on down so it's out of my way. And I end up getting x squared is equal to 3,600. So that actually does form a perfect radical. But let's say you didn't know that. So you have 3,600. So you can divide that up into 36 and 100. So I'm just going to show you, let's say you didn't know that was a perfect square, how you would do that. Well, we can break that down to 6 and 2. 6 is 2 and 3, 2 and 3, 100, 10 and 10, 5 and 2, 5 and 2. So I end up having a pair of 2s, another pair of 2s, a pair of 5s, and a pair of 3s. So 2 times 5 times 3. And you multiply all of those together and you get 60 feet. So the ladder is extending 60 feet from the house. So let's take a look at this next one, a ladder that is 42 feet long. So again, here's my house. And then it's a tree. Oh shoot, that's not what I wanted. Watch my tree drawing, that's why I wanted to do it, because it's so much better than my house drawing. So there's my tree. Okay, so then we're standing against a tree. And the ladder is 52 feet long. And it says that the foot of the ladder is 20 feet from the tree. So that's 20. And we want to figure out how high it is from the tree. So what we're going to do is we're going to do x squared plus 20 squared plus 52 squared. Because again, 52 is my hypotenuse because the tree forms a right angle with the ground. So then we get x squared plus 400 is equal to 52 squared, which is going to give me 2,704. So then I'm going to go ahead and I'm going to subtract 400 from both sides. And I end up getting x squared is equal to 2,304. So then I'm going to take the square root of both sides. So let's go ahead and let's simplify that radical, 2,304. Well, I see that it's going to be divisible by 4. So I do 4 and 576. Well, 4 can break down to 2 and 2. 576 I can divide by 4 again, and that can be broke down to 4 and 144. Well, 4 I can break down to 2 and 2. 144 I can break down to 12 and 12. 12 breaks down to 4 and 3. 4 breaks down to 2 and 2. 12 breaks down to 4 and 3. 4 breaks down to 2 and 2. So I have one pair of 3s, one pair of 2s, two pair of 2s, 3 pair of 2s, and 4 pair of 2s. So I have 2 times 2 times 2 times 2 times 3, which is going to give me 48. And everything ends up in a pair. And my original label is feet. So it's 48 feet up the tree. So that concludes your note video for today. Go ahead and show me your completed note sheet when you are done. Thanks for listening.